Okay, so last time we started the topic of traffic data collection, and the title of the topic also mentioned data reduction, which I told you is representing the entire data with few representative values. So we studied why do we need traffic data. We studied about the things which we include now in the traffic data. It's not only about vehicles. Some sources of traffic data collection. We have some existing sources, and then there are data collection methods. Okay. So I mentioned we have handheld methods, okay, where you are doing the counting yourself one way or the other, okay. And then we have some detectors which can do the counting for you, okay. So you install them on the side and then the counting will be done automatically. Some of these detectors can be installed on the side of the roads. Some of these detectors are installed under the road. The ones which are installed on the side of the road, they are called as side fire or radar detectors because they are above the ground, okay. So they measure or they do the counting using some kind of energy transmission, some kind of rays, okay. There are different types of rays or energy transmission which they use, but they are above the ground, so they can do that. But point detectors, they are under the ground, okay. So they cannot be radar. Get my point? Okay, because they are under the road, they are buried under the road, okay. So those are called as point detectors. And then this is something which some of you have already done, okay, which is to take video measurements, okay. And one of you have used the tool as well, that you guys, right? Okay, so there are tools available which can do the counting for you. Only counting or the speed as well?
No,
just count.
and
Okay,
it's number of car and bar. Yeah.
different. Good. Okay, but we had last semester we had a MSc student who developed the software which can do the counting and which can take the speed as well. Okay, sorry.
Name of the student,
No. He doesn't even know what it is. MSc student. MSc, yes. He is brilliant, yes. When he will do masters, he will do something else. He is there, right? Where? Somewhere. He went to somewhere. Where? Switzerland. Right? Okay. Applications of traffic data. Once you collect traffic data, what can we do with it? We can use it for managing the system, knowing future trends, knowing current demand, knowing the behavior of the drivers, and calibrating equations, knowing the impact, and so on and so forth. There are different types of traffic studies which we can do. Okay, there are some of them are mentioned here, but they are not all. They are not all, but they are very basic and they are very common. Okay, which one of them would you do or you have already done in this course? Which one of them? Volume study and speed. Okay. I'll come back to the travel time study as well, okay, but this is something which is linked with the speed study, but not in this way. So volume is a measure of demand. We did one example end of last lecture, okay. We were looking at the volume, okay, and when the demand increases, volume generally increases, right? Okay, but what is the catch? If the demand keeps on increasing, the volume will keep on increasing? No? Then point of capacity, okay. But up till a certain point, it can be taken as the measure of demand, okay. Clear? And after capacity, when it reaches capacity, then you know there is a problem. If the volume is maintaining at capacity, then we know there is a problem. We cannot know the demand, but we know there is a problem. Got it? Okay. So volume is used in planning and design. I mentioned which volume we use in planning and which volume we use in design. Daily for planning and hourly for what? Very good. I forgot to raise the quiz. Okay. So hourly is used for all the other things. Okay. traffic control, traffic operation, detailed signal timing, hourly is used in all of them. Okay. Yeah, but they are now going to more accurate methods, okay, where they can use volume of smaller intervals, but then it needs, you know, the software which can handle that much data, and there needs the tools which can collect the data with smaller time intervals. Okay. Then we have speed studies. The speed studies are a major concern for safety. Okay, they are the very there is multi-dimensional link between speed and road accidents. Okay, if the speed is high, the chances of accidents are high because you get less time to react. Okay, but still we have more time to check the phone, right? You were saying I was going very fast, right? No? No? You did. Done. Yeah. But when obviously looking at the phone, everything goes fast, right? But the point was, speed increases, chance of accidents increase. Okay. What about the seriousness of the accident? Speed is higher, accident will be more serious as well, right? So the number as well as the seriousness is increasing because of, or it can increase because of speed. Okay, so that's why speed is our primary safety concern. So when we set up the speed limits, we have to take into consideration all these things. Okay, so speed limits are set according to road conditions and driver expectation. Okay, we're looking at road conditions and driver expectations. Okay, so road condition, okay, I can have some equations. If the road is this much width and this many lanes, I can expect this much speed, or this is the curve. You have seen the equation of the curve, right? Designing a vertical curve, horizontal curve. So the speed is there. Okay, but what about driver expectation? So for that, I have to do speed studies. Okay, so the point was, safety is very much linked with the speed, and speed depends upon driver behavior as well, and you cannot know that without doing speed studies. Then we have travel time studies. Okay, now travel time is linked with safety or not? Time is linked with safety, right? Many of you have done the speed of the distance upon time, right? The law of velocity, right? Doesn't? Okay. So why are we discussing travel time separately? Travel time studies separately. Speed studies, I showed you earlier as well when we were discussing time mean speed and space mean speed. Okay. That for space mean speed, we have to take the entire segment. This is where we can do travel time studies. Okay. But we know speed can be for shorter segments as well. Speed can be for a point as well. I already told you there are apps available. Okay, and that MSc student also develop an app where you can find the speed of the vehicle when it is passing a point. So speed studies do not have to have travel time. They are linked. But when you are studying them, when you are taking speed values, you don't need travel time always. Got it? Clear? Okay. Secondly, the people who are doing distance upon time, I was asking you how much distance did you take? Okay. So if you take the distance very small or very big, okay, it will have a lot of impact on your travel time. If I take this distance very small, people who have taken 40 meters, 50 meters, your time could be in 1 or 3 seconds. Okay. If you've taken it higher, okay, then your time will be maybe more than 10-20 seconds. Okay, so the value which is 10-20 seconds is more stable. Okay, the value which is within 1 or 2 seconds, it's like a fraction, it's passing like this. Okay, so those times which are taken for very small distances, they are not considered valid for travel time studies, because in this much time, in this much distance, your travel time is not stable. Okay, so that's how travel time studies are separate from speed studies. Speed studies can be done for short distance, even for a point as well. But if you have taken travel time of this much distance, it will not be considered a valid travel time. Okay, clear? Still, speed is still considered valid, but the travel time of a smaller distance is not considered valid for engineering, traffic engineering purposes. Got it? Clear? The point of the matter is that it should be done for a longer distance. Travel time studies should always be done for longer distances. It can even go from point A to point B, which could be in different cities. Okay, but obviously speed studies will not be like this. Yes. Which one? Yeah. If you are using travel time, a proper travel time study to calculate speed, then it is considered as space mean speed. Okay. Why we do travel time studies? When you are passing through a highway, when you have a selection to be made, okay, this highway, this route, this route, okay, what is the criteria of your selection? Travel time, right? So what are you? You are part of the demand of the highway, right? And the demand is because of travel. Okay, got it? I am making the decision, right? When I make the decision, I will go from this highway. I will be part of this demand of the highway, right? Yeah. And what is the basis of my decision?
Not always.
Huh?
Not always.
Not always, but like normal people. Not Sultan like. So you get the point. Okay. So the general trend is the travel time dictates your decision for the demand of the highway. Okay, it's the other way around as well. Okay. Sometimes the demand keeps on increasing. When the demand is increasing, travel time is, what is happening to the travel time? Decreasing. Increasing as well, right? Yeah. Travel time is also increasing. When the travel time will reach a certain limit, people will no longer go to that highway because now the travel time is too high. Got my point? Okay. So travel time is used. You are asking me how do we calculate the demand, right? And I gave you the planning perspective. In long-term planning, the demand is calculated using a population and activities. But in short term, for traffic management, if I want to calculate the demand of a highway, I will use travel time in my equations. Okay? Got it? Clear? And you can see the relationship. Travel time is lower, demand will be higher. Okay? More people will go towards that highway which has lower travel time. Okay? But it's iterative, it's cyclic. Demand increases, travel time will also increase. Then this will start decreasing as well. Okay? So there's an equilibrium. Okay, then we have delay studies. Okay, this happened to my friend. Okay, delay is part of travel time. Delay is a part of travel time, right? Okay, which part of travel time? Huh? The worst part. And how do I define it? How do I define it? Stopping a traffic signal. Any obstruction. Okay, what else?
In the queue.
Yes?
Queue.
When you are in the queue. Okay, so all these are true. Okay, but basically a slight modification. Delay is considered anything which is more than the expected value. Okay, delay is considered anything which is more than the normal or expected value. Okay, so the part of the time which you feel annoyed, okay, because you feel that I could have gone faster. Okay, and it could include all these things: stopping at a signal, obstruction, queue, all these things. Okay, but just a small clarification here: delay is not equal to stopping. Delay is not equal to stopping. Okay, because you may not be stopped, but you are still feeling I am delayed. Okay, I can go faster. So it can happen at intersections or mid-block locations. You will see this word mid-block used in the book and the slides. Mid-block basically means not intersection, simple. Okay, which is not an intersection is a mid-block. Okay, no entry, no exit. A straight road is a mid-block. Okay. Then we have density studies. What is density? It's a good thing I'm doing it on quiz. What is density? Over some distance. Okay. And we discussed earlier that it's very difficult to measure because the vehicles move. Okay. You need them to be constant over the entire distance so you can count them, which normally doesn't happen. Okay. So in the last chapter we saw some equations which had density. You can use those equations. And then this slide shows you a detector which can give you the values to calculate density. For example, this is my detector. This is my vehicle. Okay. The length of the detector, LD. Length of the vehicle, LV. Okay. So when the vehicle will come over the detector, this will be called as occupancy. Okay. What is occupancy? The time when the vehicle is over the detector. Okay. Will the detector be always occupied? No. When one vehicle will leave, the other one will come. There will be a small gap between them, right? Or maybe a large gap between them. Okay. So my occupancy is not 100%. Got it? My occupancy is not 100%. Okay. Occupancy is the time when the vehicle is over the detector. Okay. When one vehicle moves, the other one will take some time to come, right? So my occupancy is not 100%. Okay. So O is the percentage of occupancy you have. It will not be 100. Clear? Okay. So once you have length of the detector, length of the vehicle, and the occupancy value, you can calculate the density using this equation. Okay. And this equation, LD is fixed. This is my detector, it doesn't change. LV is almost fixed. Almost fixed. Okay. Like you have to specify what type of vehicles you are doing it. Okay. So almost fixed. And O is the value which you are taking from the detector maybe after every hour. Got it? Okay. O is the percentage of time, right? When the detector is occupied. It could be one value for this hour, some other value for the next hour. Got it? Okay. Okay. Then we have accident studies. Accident studies obviously focus on accidents. What data of the accidents we are interested in? We are interested in rate of accidents. Okay. So rate means a ratio, right? Okay. We have rate per unit time, acceleration rate, and we have rate per unit distance as well, right? Okay. So accident rates. Okay. At what rate they are happening? Per year, how many? Per mile, how many? Okay. Per unit vehicle, how many? Okay. So rates. And then we have the cause of accidents. Very important, right? Why the accidents are happening. Okay, so how many are happening and why they are happening and then where they are happening. Okay, so the rate, how many? Okay, why and where. Okay, why the rates are important? Because if you just take the numbers, it can be misleading. Okay, so for example, if I say that I have, let's say, 2 students which are having F in this course. Okay, 2. Okay, is it good or bad? We don't know until we know the whole class size. Okay, if it is 2 out of 2, obviously 2 out of 4 is still bad. Okay, if it's 2 out of 100, who cares, right? What's my point? So that's why the rates are important. The point was the rates are important so that you can have an idea, okay, what we are talking about. Okay, so the same number of accidents which are happening in Bahrain, okay, may be more alarming as compared to the same number which is happening in Saudi or which is happening in Karachi or India or something, because of population. Okay, got it? So then we have parking studies. Parking studies are to know the parking supply, to know the accumulation of vehicles, and to know the parking demand. Okay, parking supply means parking spaces. Okay, and the word inventory here means they record. Okay, so inventory means you take a complete record of the parking spaces. Record meaning where are they, how many are they. Some of them are reserved, right? Some of them are reserved. Some of them are at different locations and angles. Okay, some of them are parallel parking, some of them are inclined parking, some of them are other types of parking. Okay, some of them are reserved for only taxis. You go to the airport, you'll find them, right? Some of them only reserved for taxis. You go to the mall, you'll find some of them reserved for their own trucks. Okay, so this whole information set is called as inventory. Okay, this whole information set is called as inventory. Then we have, so parking spaces, record. Then we have accumulation. Accumulation means at a given time how many spaces are occupied. This is accumulation. Okay, at a given time how many spaces are occupied. And then we have parking demand. Parking demand means in the whole day how many vehicles have used the entire area. Okay, or in a specific time period. It can be one full day, it can be 12 hours or 16 hours, no problem. But in the whole time period, how many vehicles total have used this entire area? Got it? Okay, so accumulation is at one time and demand is for the whole time period. Got it? Clear or not? Okay, now all of you have come to this building, okay, but it doesn't mean that all of you have parked in this in the same lane, right or wrong? Okay, so you have your own preferences, right? You have your own choices. Okay, so parking also depends upon the choice of the driver. Okay, there are some people who may park at some distance and they would like to walk. Okay, because they feel their parking space is under the shade and so on. And there are others who will say, okay, no, I will park near the gate. Okay, even if there is no shade and so on. Got it? So that's why parking studies may involve interviews as well to the drivers to know their choices. Okay. Another important factor is how much they would like to walk from the parking area, for what purpose they are using the parking area. Okay, clear or not? Okay, the same parking area may be used by an employee and a person who is just coming for grocery shopping. Their parking choices will be completely different and their duration is also different. Okay, so that's why. Then we have goods movement and transit vehicles. Goods are moved through trucks and transit refers to buses. Okay, so trucks and buses. Trucks and buses. So these studies are about heavy vehicles. Okay, the study of heavy vehicles. Clear? Why heavy vehicles are important? Why we need to study them separately? Because they are slower. Okay, so they may cause more congestion. Okay, they may have more impact on the traffic as compared to cars. Okay, if you keep the number of vehicles same, but you increase the percentage of heavy vehicles, the traffic situation will completely change. So I have 1,000 vehicles now, after 1 hour still 1,000 vehicles. Okay, but now the number of heavy vehicles has increased from 4% to 10%. So you will see the complete difference in the traffic situation. Okay, you don't feel it, but you will often see it during the morning times because there are lots of buses going and coming. Okay, so we need to take their inventory, their record, which routes they go, because they cannot go at any route like cars. They have fixed routes. Okay, a truck goes from this place to this place. They have the industrial area here or port area here and so on and so forth. In buses, they have their own routes. Okay, so you have to specify their routes and you have to plan for them. Got it? Okay, then we have pedestrian studies, obviously for pedestrians, and why they are important, because they are more likely to get injured during accidents. So you have to make sure that they can safely use the highways. Where they are using the highways? When they are mainly crossing. Okay, so you have to provide them safe locations for crossing. Okay, it can be at the same level, or you can make them elevated pedestrian bridges. Okay, or underground as well. But you have to know their number, the time they need to cross, the location where they want to cross. Okay, there are many pedestrian bridges which are just built using thousands of BTs, but nobody is using them. Okay, so you have to do some studies to know what should be done at that location. And obviously it's a matter of choice, right? I cannot know why people want to cross from their location until I ask them. So you have to do some pedestrian interview studies as well. Calibration studies. You have seen these equations, right? Okay, we use them. We derived them, right? And the derivation started from where? It was a graph between speed and density. Okay, so the data which is collected for developing the equations called calibration studies. Data collection for developing models and equations is called calibration studies. Got it? Clear? So for developing equations, you need real data. And real data, when it is collected for this purpose, called calibration studies. Then we have observational studies, in which we call them follow-up studies as well. Follow-up, observational, before and after studies, same meaning. Meaning that you have made any changes on the highways. Okay, now you want to see the impact of your change. Observational studies are done to know the impact of recent changes, which could be good, which could be bad. Obviously, you had some good intention in your mind, but you have to see the actual case as well. Now, what is actually happening? Got it? Clear? Okay, stop here.